This Module 2 help video will help you with assignment 2.04, complex zeros. The first type of question is going to ask you to write the expression in standard form. So what you have to remember is we don't want to have one of the i's or complex numbers in the denominator. So what we're going to do to get rid of it is we're going to multiply by its conjugate. So remember, conjugate is essentially the same thing as what you have there currently, except for instead of subtraction, it would be addition. If there had been addition there, we would change it to subtraction to make it the conjugate. And here's why the conjugate works. Because if I multiply this out, 4 times 4, I get 16. 4 times 16i would be 16 times 4, which is 64. And then the I, so it's just going to be plus 64i. Then negative 16i times 4, guess what? It's going to be negative 64i. And then last but not least, negative 16i times positive 16i would be 16 times 16, which is negative 256. And I times I is I squared. So we can simplify this a little further because these two in the middle are the same thing, 64 positive minus 64. They go away. So the 16 is left. And then notice, remember I squared, what that meant? I squared is going to be negative 1. So instead of negative 256, it's negative 256 times negative 1, which is positive 256. So I really end up with 16 plus 256, which is 272. So my new denominator really is 272. But you know with math, anything you do to the the denominator, you also have to do to the numerator. So you've also got to do 4 times 4 plus 16i, which was the conjugate to the denominator. 4 times 4 is 16. Then we're going to go back in again, and we're going to do 16 times 4, which we did in the denominator already. We know that's 64. 64i. So 16 plus 64i. And then you're good to go. You just can't have that I in your denominator. Now, when we add or subtract complex numbers, some people overthink this, but it's surprisingly easier than what you might think. These are nothing more than like terms. So if you do the constant 4 minus negative 7, because they're both constants, 4 minus negative 7 is going to be positive 11, because a negative and a negative make a plus, make a positive. 4 plus 7 is 11. And then 4i minus I, because they're like terms. 4i minus I is positive 3i. And then you're done. Over here, same thing. You got a 5 and a 6 being added together. So 5 and 6 do make 11. And you've got 9i plus negative 2i. So that would become positive 7i. And then you're done. You've added and subtracted your complex numbers. As simple as that. Now, when you multiply complex numbers, the process is the same as if they weren't. You just got to watch out for what your products are. So we're going to start here. 8 times 7, we know is 56. 8 times 8i, 8 times 8 is 64, so plus 64, and just one I there. 8i times 7, again, we just did this earlier with 8 times 7, which is 56, but we have a 56i, so plus 56i. And then 8i times 8i, 8 times 8 we know is 64, and I times I is I squared. So we just need to simplify this a little further. You have like terms here in the middle. You got the 64i and the 56i. So that becomes 120. So you got the 120i. You got the 56 from the original plus the 120i. And anytime you see I squared, that's going to be negative 1. So instead of being plus 64, 64 times negative 1 becomes minus 64. And now, because it's done that, these two guys are like terms, 56 and negative 64. So if you do 56 minus 64, you end up with negative 8. So you can do 120i minus 8, or you might see it presented as negative 8 plus 120i. Both are the same exact thing. And that's how you multiply your complex numbers. Just keep in mind, if you have I squared, you got your negative 1 there. Remember your rules of complex numbers. So this says find the product of the complex number and its conjugate. So we just talked about what a conjugate was a minute ago. So 9 plus 9i, we're going to multiply it by its conjugate. So its conjugate, again, is the same thing, but with the opposite sign. So that's the conjugate part of this question. And then we're just going to multiply. 9 times 9 is 81. 9 times negative 9i is negative 81i. 9i times 9 is positive 81i. Hopefully you see something right there. And then 9i times negative 9i is negative 81i squared. So again, the two middles are going to cancel out because negative 81i plus 81i goes away. And you're left with 81 minus 81i squared. But we know that I squared means negative 1. So instead of 81 minus 81i squared, it's going to be 81 plus 81. And you end up with 81 plus 81, or 81 times 2, however you want to look at it, which is 162. So that's algebraically why it happens. I'm not going to give you the trick or the tip, but take a look and see if you could figure out how you could have done that a little bit easier now that you know how the conjugate works and why it mathematically works out the way that it does. And then lastly, we're going to look at how we can find the real numbers and complex numbers to make the equation true. Here you have 13 plus yi is equal to x plus 9i. So if you notice here, how can I make this true? Well, I just need to make the number in front of the I the same as the one on the right. So I need to make the y be 9. And here on the left, to make it true, I need to make the number to the left of the term with the I in it the same as the one on this side. So 13. So I need to make x be 13 and y be 9 so that it can actually be a true statement. It's as simple as that. Hope this helps you in this lesson, and good luck.